and welcome to another math tutorial. Now our task in this question, okay, is to prove that x equals to h parenthesis a² plus h² divided by a² minus h². Now let's read the question to know what is to find out what x, h, and a represent. A vertical tower and a vertical flagstaff on the tower subtend equal angles at a point on the same level as the base of the tower and a feet from it. Okay, if h is the height of the tower and x is the height of the flagstaff, then we're asked to prove for x. Let's not forget that according to the question, x is the height of the flagstaff, h is the height of the vertical tower. So let me draw the diagram. Okay, with the diagram we should be able to analyze the problem. All right, so let's have our analysis. So we have a vertical tower. So this is the tower. Okay, then we have a flagstaff. This is the flagstaff. Let me label that with letter F. Now we're given that if h is the height of the tower, so the height of the tower is h. The height of the tower is h, and x is the height of the flagstaff. So for the flagstaff, the height is x. The height is x. Now, we have a vertical tower and a vertical flagstaff, okay, on the tower subtend equal angle. So now let's take this to be the top of the tower. So the angle subtended, okay, by the top of the tower from the point of observation. You know, the point of observation is where we have the angle of elevation. All right, so now let's say let alpha equals to angle subtended by the tower. Okay, then also, so this is the point of observation. So from the point of observation, we also have that on the same level as the base of the tower and a feet from it. So that means the point of observation, from the point of observation to the base of the tower, the distance is a feet. The distance is a feet. And we know that the angle, that's the angle subtended, okay? The angle subtended by the vertical tower is what we have as alpha. So now from F also, which is the flagstaff, okay? We don't have a clue as to what will be the size of this angle, okay? That's this angle. We don't know what the size of this angle will be, but of course we can actually find out what will be the size of this angle. But let's not forget that in the question it is stated that the vertical tower and the flagstaff subtend equal angles. Okay, so what I will do in this case is, now we want to calculate the size of angle FOT. So we want to know what is FOT, okay? But let's not forget that the angle of elevation of the flagstaff, that is the angle subtended by the flagstaff, will be angle FOB. We'll come to that. So what is FOT? Now, we can see from here that angle FOB will be equals to the sum of angle TOB, okay, angle TOB and angle FOT. So if you make FOT, if you isolate FOT, now FOT will be equals to angle FOB minus angle TOB. That's it. Now let's not forget that in the question, we're given that the vertical tower and the vertical flagstaff on the tower subtend equal angles. So that means that from here we know that angle TOB equals to alpha. So if they subtend equal angles at a point on the same level, so it means that FOT will also be equals to alpha. So in that case, we're going to have from here, we're going to have alpha equals to angle FOB minus alpha. So that FOB, which is the angle subtended by the word Flagstaff, okay, at a point on the same level, that will be equals to alpha plus alpha, which will be what? 2 alpha. Now, so which means the size of this angle will be 2 alpha. So we are going to consider two different triangles in this triangle because we have a triangle, okay? We're going to consider triangle TBO. So in triangle TBO, we know that tan alpha, which we know to be opposite over adjacent. The opposite of this angle, okay, is height h divided by the adjacent, which is the base, and that's what? A. All right. So which means we have tan alpha equals to h over a. So let's note this. That's one. Then also, we are also going to consider from the Flagstaff, okay, Flagstaff to the base and the angle subtended. So that means in triangle FBO, okay, in triangle FBO. So the height, which is the opposite side, if you are considering what is tan 2 alpha, because this time we have to consider this angle FOB. So that means that tan angle FOB, okay, will be equals to opposite over adjacent. In this case, this one is tan angle TOB, which is equals to this angle TOB, which is equals to tan alpha. All right, so in this case, the opposite will be x plus h. That will be x plus h divided by the base, which is a. So which means we now have tan 2 alpha, because this is also equals to tan 2 alpha. Okay, tan 2 alpha. Tan 2 alpha is equals to x plus h over a. So let's also note this. So we are going to use this, okay, to prove for x. Now let's see how that works out. First, we need to recognize the sum to product identity for the tan of 2 alpha. You know, for tan of 2 alpha, okay, applying the sum to product identity for tan 2 alpha. We know that for tan 2 alpha, that will be 2 tan alpha, okay? 2 tan alpha divided by 1 minus tan squared alpha. And we know that tan alpha is what? H over A. So let's substitute, okay? We need to do some substitution now. So we have for tan 2 alpha, we have x plus h divided by A. So this will be x plus h divided by a, okay, equals to 2 multiplied by h over a, which is tan alpha, divided by 1 minus, now tan alpha squared, that will be h over a squared. So this is the left hand side. Why this is the what? Right hand side. So let's try to simplify the right hand side. So we have our left hand side. We have our left hand side to be x plus h over a equals to 2 times h over a. That will be 2h over a, which is the numerator. Let me do it this way. Divided by, we have, this will be h squared, a squared. So a squared times 1, that will be a squared, then minus h squared, divided by what? H squared. So this is the numerator and this is the denominator. So we have division of two fractions. So now, when this is changed to multiplication sign, this will what? Flip. So now this will be x plus h over a equals to 2h over a multiplied by a squared over a squared minus h squared. So a squared divided by a, that will be a. So in this case, we have x plus h over a equals to 2a times 2h times a, that will be 2ah over a squared minus h squared. Now let me cross multiply. Okay, there's a shortcut here, but let's do cross multiplication. So let me cross multiply. So in this case, this will be x plus h multiplied by a squared minus h squared equals to 2a times 2ah, that will be 2a squared h. Now let me expand the left hand side. X times a squared, that will be a squared x. X times h squared, that will be h squared x. H times a squared, that will be a squared h. H times minus h squared, that will be h cubed. This will be equals to 2a squared h. Alright, our goal is to make Mr. X, which is the height of the Flagstaff, the subject of the formula as far as this is concerned. So I'm going to move, okay, I'm going to move this to the right hand side and keep this on the left hand side. So on the left hand side will be a squared x minus h squared x equals to, so when we move a squared h to the right hand side, and we have 2a squared h on the right hand side, that will come here to be a squared h minus h squared h. Then when this also goes to the right hand side, that will be h plus h cubed, because it is negative on the left hand side. All right, so here x is common, so let me factor out x. Factor out x. Okay, factor out x. That means we have x into a squared minus h squared equals to 2a squared h minus a squared h. That will be a squared h plus h cubed. Okay, now let's divide both sides by a squared minus h squared so that we can isolate x on the left hand side. So that x, we have a squared minus h squared divided by a squared minus h squared equals to a squared h plus h cubed divided by a squared minus h squared. Okay, this will cancel this. So we now have x equals to, now when we look at the right hand side, we can see that h, we can factor out one h from what we have here. That's this h. So when we factor out h, we have h into a squared plus h squared divided by a squared, okay, minus h squared. And we just prove that the height of the Flagstaff is equals to the product of the height of the vertical tower and the sum of the squares of the distance from the point of observation to the base of the vertical tower and the height of the vertical tower divided by the difference of the squares of the distance from the point of observation to the base of the vertical tower and the height of the vertical tower. And we've come to the end of this tutorial. The noblest pleasure is the joy of understanding. Bye-bye.